when the block is in the green state, the 1203 points are connected so that there's a path to both the on-off section and the slowdown section.
Hello, I'm James Ingram. This video was digitized from a 1992 videotape series named V9202.
In front of the camera now is the drawing set that describes the construction of this Model 944 magnetic block that we've been talking about. This drawing set, which currently consists of 7 sheets, is part of what is referred to as the construction drawing set that's available as a package. Sheet 1, which is in front of the camera, currently is the assembly drawing. This shows the dimensions and position of the various parts on this block and how to lay them out. Basically what you're looking at is a top view of the block. Here is the 5094 motor. Back here is the 1201 switch motor and the 1203 points. Here are the 2 rheostats, terminal blocks, and the knife switch. And a little locomotive that shows the direction of travel is from left to right on this block. As I mentioned before, I believe this 5094 motor and the accompanying semaphore arms, the way this thing is constructed is essentially for looks. That is to say, you could build this block and omit the 5094 motor. It's not functional as far as electrical function goes. It's just a display item. The visual effect of having the semaphore arms in operation is what this does, but it has no actual electrical function. That's sheet 1, the assembly drawing. Going to sheet 2. Sheet 2 is the wiring diagram. Basically shows where all the wires connect to each other, what connects to what. These have a color code to them, which is listed over here, and these can be colored in with a colored pencil to make them a little easier to follow. Sheet 3 is a schematic drawing. It uses the same numbers as the previous sheet, the wiring diagram, but it tries to make things a little easier to follow. This is actually divided up into four pieces. It shows current flow when the engine is actually passing over one of the track contacts in this corner, T1. Here's the current flow shown when an engine is passing over one of the track contacts, T2. And down here shows a DC current flow when the block is in the red position, and the DC current flow when the block is in the green position. These schematics are just an attempt to make it a little bit easier to follow what's happening electrically than the wiring diagram. The wiring diagram, that is the previous sheet, shows how things actually hook up, but it's not necessarily the easiest thing to follow to understand. Let's look at sheet 4. Let's look at sheet 4. Sheet 4 is essentially a sheet full of notes, explanatory type notes. Sheet 5 is the detail for the mounting bracket that holds the 2 rheostats. Sheet 6 is an installation drawing. This basically shows how to install the block in a circle of track. Key points being that the DC power should be fed somewhere in front of the block, as shown here. Again, travel directions from left to right is indicated by the pointed shape of the locomotive pointing toward the right. Track power fed in here in front of the block. Never in the slowdown section. It won't work if you hook the track power up to the slowdown section. The 1015U has to be located back behind the slowdown block, or at the end of the slowdown block, making sure the gap is in the right rail. Then someplace, for initial conditions, I suggest putting the track contact T2, which is shown here, I suggest putting that right in front of the slowdown block initially. And what this note says for initial conditions, engine A should be the slow engine of the slower engine of the two. Engine B should be the faster engine. Engine A should have the magnet on it. Engine B should not have a magnet on it. If you push the arm in on the rear switch motor, which will set the block manually into the red state, essentially park engine B on the block, it won't go anywhere, since in the red state the on-off section should be off. They let engine A with the magnet travel around. What should happen is engine A should travel around the loop, encounter the track contact T2, change the block to B, change the block to green, which will release engine B. When the block changes from red to green, the on-off section will turn to on, and engine B can start up and leave the block. Meanwhile, engine A will go through the block, cross track contact T1, and set the block back to red again. So that should be sufficient initial conditions to get this unit into operation. The last sheet here, sheet 7, Sheet 7 is essentially a parts list and a cost estimate sheet. It shows the this column here is the list of all the parts required to build this block. And just for reference, there's some approximate costs given using the Waller's catalog for LGB cost and the Radio Shack for the cost of Radio Shack parts. And these prices aren't, of course, change over time, but just for ballpark figures, the cost of the parts for this block came to about $254, and then throwing in some estimates for labor to build the thing, I think at $5 an hour, there's about 25 hours of labor, so about $125 worth of labor to build this thing, figuring 25 hours at $5 per hour. So the total cost of this thing here is estimated at approximately $379 to construct one of these Model 944 blocks. Let's go back and revisit for a minute this sheet 3, the schematic diagram. I think it'll be worthwhile. That's the one with the 4 figures. The figure in the upper left corner, which we've got in view with the camera right now, is figure 3.1. This says heavy lines show AC control current flow when an engine is passing over track contact T1, setting block to red. And in the finer print here that you can almost read on the camera, says that AC current flow for red. When a magnet momentarily closes track contact T1, AC control current is halfway rectified by the diode and flows the direction as shown on the wire C6, excuse me. This moves the arm of the 1203 switch motor to the left, which sets the 1203 points to the red position. That should be 1201. But basically, here's your wires and the current that is flowing at this moment when track contact T1 is being actuated. It is shown by the heavy black lines. This right here represents track contact T1. The diode may or may not show up on the camera, but the diode is right here. It points up toward the top of the paper. So since it's AC current trying to flow through a path that has a diode in it, the current has no choice but to go only one direction. That's the direction allowed by the diode. So since you get half of that AC wave rectified to a DC current, so you've got essentially a DC current as a result of this diode doing the rectification. So the current will flow in the direction shown by the arrows, which will push the arm of the switch motor in toward the track, which will set the block to red. Now let's look at figure 3.2. Figure 3.2 says heavy lines show DC current flow to the track when the block is in the red position. And the finer print over here says DC current flow for red. When the block is red, current for the right rail does not flow to the on-off block. It comes in via wires D1, D9, D2, D10, and stops at the open points. Current to the slowdown block flows via D1, D7, R1, D8, D5, D6. So again, the heavy black lines show the wires that have current flowing on them when the block is in the red position. Basically, here's the block. Here's your slowdown section to the left of the block, and here's your main track to the right of the block. The block pulls power in from the main track off of the right rail via this wire D1. When it's in the red position, there's no path for current to get to the on-off section. That you can see the little line representing the 1203 points is open, so there's no path through here to get to the on-off section. So the on-off section is completely off. However, current can get to the slowdown section via the path going through the rheostat R1, which is what's shown here. So you're getting reduced voltage at the slowdown section because the current is coming through this rheostat R1 and flowing to the slowdown section. Okay, now we're looking at figure 3.3. This says heavy lines show AC control current flow when engine is passing over track contact T2, setting block to green. So here's track contact T2, and the heavy lines show the current flow. Now, track contact T2 is wired so that the current is passing through the diode going in the other direction, which on right here where I'm pointing, it's going toward the bottom of the paper. So current has to flow. It's AC current being rectified by a diode to a half wave rectified current. So the current has to flow in the direction shown by the arrows, which it does, which pushes the arm of the switch motor out away from the track, which changes the block to the green state. Here's figure 3.4. This one says heavy lines show DC current flow to track when block is in green position, and the finer print says DC current flow for green. When block is green, current for the right rail flows to the on-off block via wires D1, D9, R2. R2 means rheostat 2, D10, D2, D3. Current to the slowdown block flows via D1, D4, D6. So again, here is the block, the shaded rectangle, the slowdown block to the left of it, and the main track to the right of it. So when the when the block is in the green state, the 1203 points are connected so that there's a path to both the on-off section and the slowdown section. Power or current to the on-off section comes in from the right, goes through the rheostat R2 across the points, which are now connected, and goes to the on-off block. This rheostat R2 is what I was referring to when I was showing the block itself as the forward rheostat, which can be used to drop the voltage to the on-off section, so that when the block changes from red to green, you get a little bit reduction in voltage, so the engine doesn't jerk the train so hard. Now you do get an unwanted side effect that when an engine goes through a block that's green, it will still see this rheostat, and it'll slow down a little bit when it's going through on a green block and not even stopping, which is essentially an unwanted side effect. But it's no easy way to prevent it without a really much more complicated control scheme. Meanwhile, going to the slowdown section, when the block is in the green state, now the current doesn't have to go through rheostat R1. It can bypass it and go directly to the slowdown section on a wire, so the slowdown section is essentially getting full voltage when the block is in the green state via this path.